The HCA cluster is used to perform hierarchical cluster analysis. Here again I put all traits in the Y field, and then the factor variety name in the X field. I'll also split it by the germplasm category factor by clicking here, and then move this factor into the field. Then I can select the clustering method and click OK. Results show clustering of varieties according to their traits profile for each category separately. Going back, I can change the clustering direction by clicking here. So now the traits are clustered according to varieties. The PCA cluster performs principal component analysis. The use of this is quite similar to the HCA. I put traits in the Y field, and then the variety name in the X. Also, I can put one or more traits in the colors field that will be used to color data points. Let's put here fruit weight. Data points represent varieties that are scattered according to their traits profile. I can see the variety name by pointing the mouse over the data point, and the color represents the fruit weight value. As usual, green is low, black is average, and red is high. Varieties that are located close to each other have similar trait profiles. To visualize this, I can select several nearby points from the figure and depict their traits value. Let's select this one. They're put in the table below, and then go. And this is how it looks. Below there's the variety name, and each bar represents one of the traits. I can point the mouse to see the trait's name. Importantly, we can see all these selected varieties have very similar profiles. Now I can go back to the figure and select points that are far away from each other. Let's pick these ones. Now the traits profile for the selected varieties are very different from each other. As a last option, I can select several traits to put in the color field. Let's move the fruit weight from here, and let's say I want to take these ones and put them in the color field. Then click OK. Now, instead of data points, we have boxes that are comprised of several colored squares. The box represents a variety, and each of the little squares in it is one of the traits used in the color field. We can point the mouse to see the variety name and all of its traits data. The Cloud 3D is used to draw three-dimensional scatter plots that present data points according to three selected traits. So, first I select three traits and put them in the Y field. Then optionally, I can pick a trait that we'll use to color data points. Let's pick this one. Then I put the germplasm category in the split by field. And this is the resulting figure. I can click on each of the two panels to zoom in on a particular box. After the zoom in, all data points can be pointed at by the mouse to view their name and traits data. Also, points can be selected from the figure to be saved in a new list, just like it did in the other analyses. The multiple t-test analysis is used to compare statistically all levels of a factor to a common control in several continuous traits, and then display p-values as a table. Let's select traits and put them in the y field. Then we put in the x field a trait whose levels we want to compare. Here, this is the variety name to compare among all varieties. Then we click on Compare Means. In the pop-up window, we select the test that we want to perform. And then there are all levels of the x factor, so we can select the common control to compare all other levels to it. Let's select this one as a control. The alpha is used as a threshold value to filter only levels that are significantly different from the control. The resulting table shows the level, or variety name in this case, then the trait, and then the difference as a percent compared to a common control, and then the p-value. The table can be downloaded into Excel.